Hi everyone. Today is Wednesday, November 30. So I just give you back your exam 3. So exam 3, our high score is 100. Yes, perfect score. And the lowest score is 2. Average is 70.81. Okay. So we have 5A, 6B, 4C, 2D, 3F, and 5F. So the 8F, similar to exam 2. Uh, but we have 5 students did not take the exam. Okay. So, all right. Do you think the practice exam is similar to the actual exam? Yes. So for many word problems, I actually just changed the numbers. The word problem are the same. So let's look at the solution. So this is the first problem, right? We have secant 60 degree times tangent 30 degree, and secant 60 degree is 2. Tangent 30 degree is 1 over root 3. That's why you get 2 over root 3. Almost everybody get this problem right. And then part B, when the angle is outside of the first quadrant, you need to look at the reference angle, right? 120 degree is actually in quadrant 2. Yes. So you see the reference angle. The reference angle is 60 degree. So sine 120 is plus or minus sine 60, but because the sign in the second quadrant is positive, that's why we get positive sine 60 degree. Yeah, everybody? And sine 60 degree is root 3 over 2. How about cotangent? Negative 135 degree. Negative means we go clockwise instead of counterclockwise. So we go clockwise. Hi, Drake. Come and pick up the exam. So we go clockwise for 135 degrees. That's why this angle, this reference angle, is 45 degrees. And we are in quadrant 3. Quadrant 3, our cotangent is positive. Right, everybody? So therefore, cotangent, negative 135 degrees is cotangent 45 degrees, which is 1. So our answer, root 3 over 2 plus 1 is root 3 over 2, root 3 plus 2 over 2. Okay, so this is problem 1. Let's look at the common mistakes. So common mistake here. Yes, so here, you don't need to change the angle to radian, okay? So what we need is the sine of 120 degrees. Change to radian does not help. So what's the sine? What's the cotangent of that angle? And then here, this is plus, okay? Because it is in the third quadrant. Third quadrant, your cotangent is positive. Are you familiar with the fourth quadrant, your 6 trig functions, whether they are positive or negative? We cover that in the review session, right? So where's the review session? Okay, so reviews practice exam 3, yes, here. Okay, we talk about that in the review session. So I really hope everybody can watch the review session recordings, because all the concept we need, I actually cover that in more detail in the review session. So I hope all of you then study hard and then watch the review session recording. And make sure you are able to remember all the steps, how to solve each kind of problem. Okay, everybody? And by the way, do you receive my email about the class evaluation? Yes. So extra credits, because I only can see the overall response rate. So if if the response rate is 90%, then everybody can get 0.5% extra credits. 80%, 0.4, 70%, 0.3, 60%, 0.2, 50%, 0.1. Okay, so thank you so much. Your comments are so important to me. And I understand this is a hard class, but I hope you can like not only learn the math, but also learn the study skills. Like how do we like take notes, summarize the steps, and how do we learn from it? Like we know one problem, how do we able to summarize the steps so we can solve all the problems of this type? And so yeah, next week we're gonna take a class photo, and also we will you can like come to my office hours or come early before class uh, to show me your notes. Okay, so your note taking bonus. Yes, next week. Right. Do you know next week is the last week of class? How fast? Yeah, next week is the last week of class. So you show me your notes next week. Then you receive 1% note taking bonus. Right, I see. Okay. Okay. Thank you. Yeah, so we're Wednesday. So next week is the last week of class. And then, by the way, our final exam is not on Monday, it's actually on Wednesday. Okay? So which is good. We can have more time to study. So my question for you is, do you want my review session on Wednesday or on Friday? Because we might like cover something new on the Wednesday and Friday. So do you want to have the review session on Friday? Is that Wednesday? How many of you think Wednesday is better? Raise your hand. How many of you think Friday is better? Raise your hand. Okay, again, Friday better? Raise your hand. 1, 2, 3, 4, 5, 6, 7. Wednesday better? Raise your hand. 1, 2, 3, 4, 5, 6, 7. Hey! Oh my god. Who didn't vote? Take a time again. Wednesday, raise your hand. 1, 2, 3, 4, 5, 6, 7. Okay. Friday, raise your hand. 1, 2, 3, 4, 5, 6. What? 6? Okay, so Wednesday we. Okay, so Wednesday. But yeah, then maybe we will cover some problems that we haven't learned in class. Yes. Oh, and also by the way, on the Tuesday, I will be in the study sessions. So I will send you an email. The study sessions, I think it's from 6:30 to something. So I will send you an email. So if you have questions, you can come to the study session in person and you can ask me questions. And then we also have the 2-hour review sessions. Right. Okay. All right. So that's our plan. Yes, I know our class is hard because we are like squeezing algebra and trig into one course. And that's challenging. We have so many things to learn. Right. Okay, so I hope you can try your best and let's try our best to do well on the final. Okay, problem 2. Do you know this is exactly the quiz problem? Do you realize that? No, it's actually the same quiz problem. Was that quiz 7 or quiz 6? Yeah, quiz 6. Yeah, the problem 2 is exactly the quiz problem. You see, everybody? So, okay. So I really hope that you have a mistake book. Okay, so if you make the mistake before, you can collect it in your mistake book. Then before the exam, you can review your mistake book. Okay, because I asked this problem on the quiz, and then I asked this the same problem on the exam, but not everybody can get full credits. Okay, let's see what are common mistakes. So here, 5 squared is 25, not 100. And plus 2. And here, so sine is y over r, and the y is 12, right? Yeah, negative 12. So that's why it's 12. And here, the parentheses. Don't forget the parentheses. Okay, here, when you have plus, you get positive 169. Square root of 169 is 13, so no square roots again. So I think I've seen this mistake in the quiz. That's why I really hope that you can do the mistake book. If you make the mistake before, kind of remind you don't make the mistake again in the exam. We learn from our mistakes. Yeah. Okay. Yes. Okay, and then problem 3. We have cosecant is negative 5. So cosecant is like 1 over sine. Sine is y over r. So cosecant is then r over y. Remember, r is always positive. Okay? So negative 5 is like 5 over negative 1. So you pick the r to be 5. Your y is negative 1. So your x and y could be positive or negative. But your r is always positive. Is that clear, everybody? So many of you make that mistake. And then we plug in the Pythagorean theorem, right? We can find the x is plus or minus square root of 24. But because tangent is positive and cosecant is negative. So tangent is positive on 3. Oops. Cosecant is like sine. It's positive on quadrant, what? So sine, cosecant is negative. So that's quadrant 3 and 4. That's why the angle must be in quadrant 3. So the x is negative. So x is negative square root of 24. And then you can find all the 6 trig functions. So common mistake here, because it's in quadrant 3, so x is negative. So that's the mistake. And then here, cosecant is r over y, so not x over y, okay? So yeah, that's the mistake. And then also here, cosecant is r over y, not x over y. Here, quadrant 3. Okay, and r is always positive. The y is negative. Okay? And this is problem 1. And then here the x is negative. See, the third quadrant, and then x is negative. Okay, so that's problem 3. Problem 4. Okay, we have similar problem in the practice exams. The angle of elevation is this angle, okay? And tangent theta is 15 over 26. Therefore, theta is arctangent of 15 over 26. You can either use degree mode, then you get 29.982 degree, or you can use radian mode, then you get 0.523. And then let's look at the common mistake. So here, tangent opposite over adjacent. So 15 over 26, not the other way. And then this is tangent theta. You find the theta by doing arctangent on both sides. Here, see, to the arctangent on both sides. Here, 26 is not the hypotenuse, it's the shadow, the length of the shadow. So yeah, the adjacent is 26. Here, this is the same mistake as that. Okay, yeah, angle of elevation is this angle. Okay, not that one. So that's why if you watch the video session recording, then you know the angle of elevation is this theta. I know I provide a lot of resources to you, but you really need to digest the stuff. Use those resources. Okay. Okay, so next one, problem 5. Here, area 1/2 theta r squared. The theta must be in radian. Okay, that's why 250 degrees changed to radian. And then we can plug in this formula, 1/2 theta times r squared. R is 12. That's why we get 100 pi. Okay. And let's see the common mistake. The common mistake is, first of all, R is not 250, R is the 12. And then the angle, this is not pi, this is angle theta. Theta is this angle, 250 degrees, and you need that in radian. And so here, yeah, the theta is good, but the radius is 12. 12 is not the diameter. Okay, so that's why I hope you can do the practice exam first, and then use red pen to grade your work. Okay, if you have mistake, write down the correction next to it, so you know your mistake. Then you know how to improve. Okay, everybody. So we learn from our mistake, so we can improve. Okay, and then problem 6. We have, so 5 steps, right? Step 1, figure out the theta. And step 2, figure out the sine theta. So these values are from where? What's the formula? Here. Okay, do you remember that? So remember these, okay? All these 6 trig graphs. Okay, so yeah, sine, we need these ones. And then theta, the angle is 2x. Find the x. X is theta over 2. Therefore, you find this column. And then y is 4 times sine and plus 3. So you find the y column. And then look at your x column and y column. Plot the points here. And then connect the points smoothly. The sine has period 2 pi. And use it to divide it by the coefficient of x in the argument, the angle. That's why we get pi here. Part B, tangent. So first you copy down these guys, and then find your x. So this is theta, find your x, and then find the y, and then look at your x and y to plot the graph of tangent. Okay, and period for tangent is pi. And coefficient of x inside the angle is 1, so pi over 1 is pi. Cosecant. So cosecant, you need the theta and cosecant theta. And then figure out the x. And then figure out the y. Plot the points and whatever secant, cosecant, up, down. Right? Period. 2 pi over the coefficient of x, which is 3. And let's see, mistake. So here the setup is right. And then find the x. See, theta is the angle 2x. And then find the x. Find the y. Okay, so if you have questions, ask me. Okay, we did a lot of examples in class and in the review session. But if you don't understand, come to ask me. Okay? Here, the theta value is this, not that. Okay? So these values should be the theta value, and then this is the sine theta value. Okay. And then here, these are the theta values. This is sine theta values. So yeah, these are wrong. Okay. So it's yeah. And here, this is right. But when you divide it by 2, see, you still have the pi. So your angle usually will have the pi. And then here, so yeah, these values are wrong. That's why it is wrong. Here, the theta values are wrong. It's from minus pi over 2, negative pi over 4, etc. So remember to watch the recording. And yeah, come here and pick up your exam. So Derek and Aaron. And also, yeah, this one. Okay. When you draw the picture, make sure your picture is smooth. So, because this is a function. Your function should pass through the vertical line test, so you should not have a vertical line. All right, everybody. Hey, be careful! Look at me. So be careful. Your graph. Be careful. Draw it smoothly, not like that. Okay, and yes. So these are the common mistakes. And cosecant and secant, up, down, up, down. Okay, so you have up, down, up, down. And then, yeah, these are the theta values. Okay, oh, this is pi over 2, not 2 over pi. So be careful. All right. Yes. Yeah, those are the also common mistakes. Okay, next problem. Number 7. So we let this be theta. Cosecant theta is hypotenuse over opposites. And then you write down the triangle. Cotangent adjacent over opposites. Let's look at the common mistake. Here the common mistake, this is minus by the Pythagorean theorem, right? This is hypotenuse minus this guy's square. So that's the common mistake. And then problem 8. This is a typo. This problem 8 is not problem 4. Omega, the angular speed is the angle over time. So 5 radian over 34 seconds. And then linear speed is the angular speed multiplied by the radius. That's why you use this number multiplied by 7. Okay. And then here the common mistake is, right, angular speed, omega. Linear speed is omega times radius. Okay. And then the last problem, we talked about that in the review session, right? After 1 minute, you multiply the 300 by 60 seconds, you get 18,000 feet. And then you want to find the altitude. So the 18,000 feet is the hypotenuse. You want to find the opposites. Opposite and hypotenuse, we use sine 22 degrees. So that's why h is 18,000 times sine 22 degrees, which is 6,742 feet. And this is part A. Part B, you want to know how long. So you want to find the time so that the plane climbed to an altitude of 15,000. First of all, you want to find the distance. Well, you know the opposite. You're looking for the hypotenuse. So sine 22 degrees is opposite over hypotenuse. We're looking for D. That's why both sides divided by sine 22 degrees and multiplied by D. We get 40,042 feet. And then the time is, we use distance divided by the speed, which is 133.473 seconds. Okay, so yeah. This is problem 9. Thank you. Common mistake here. Right, yeah, part B. See, part B. This is distance. We want to know the distance. So this is not 18,000. Part A is 18,000. Here we want to find the D and then plug in the speed to find the time. Okay, so that is our exam 3. Okay. By the way, if you go to Blackboard, you can check my grades, and then you can see the homework average and the self-assessment average. So we only have less than a week left. Okay, so if you miss some homework, you miss the practice exams, miss the exam correction and wrapper. By the way, some of you forgot to turn in the exam correction. Exam correction is 5 points. Exam wrapper is 5 points. Okay, so please check your scores on Blackboard. If you don't get 10 points, usually I put a comment there why you didn't get 10 points. Please submit those missing work. You can gain the 5 points back. Is that clear? The last day I accept late work is the next Friday. Okay, so all your homework, practice exams, exam correction, and wrapper, please submit as soon as possible. And please do not wait until the last day to submit your work. Because, for example, if you submit your exam correction and wrapper, and then I realize, oh, you missed exam correction, so you only get 5 points out of 10. So I tell you, then you can fix it. You can resubmit and gain those 5 points back. But if you submit your work on the last day, okay, I graded, but it's already past the deadline. There's no way you can fix it. Okay? Please submit your work as soon as possible. And then, yes. So that Friday, next Friday, December 9th, is the last day I accept late work. Because except the practice final exam. Except the practice final exam is due on the final exam date. Okay, but everything else you must submit by next Friday. Then over the weekend, I will calculate your grade, and then I will email you to ask you to help me to check. Okay, so if there's something I miss, you can let me know. I can change it. Okay, then after the final exam day, I will grade your exams, and then I will post your grade on the next day. At that point, there's nothing we can change your grade. Is that clear, everybody? Mm-hmm. Yes. Okay. Yeah, I know our class is tough. It's hard a lot, and I'm glad you make it through. And I really hope that you can pass this course so you don't need to take it again. Okay? So, and I'm excited to see some of you in the Calculus 1 next semester. All right. Okay, so that is the exam, right? So I posted the exam 3 solution on the website, then you can make corrections and then submit that in Blackboard. By the way, did I tell you this Excel sheet you can use to calculate your grades? Yeah, so you can plug in your exam 1 score, exam 2, exam 3, and the final exams, and then your homework average, quiz average, self-assessment, extra credit, and then you can calculate your scores. Then you can see how many points you need on the final exam so you can pass the course, or get B, or get an A. Okay. All right. Yeah. So after you finish calculating, you can delete your score. So other people won't see your score. So even though, we don't know your name, so yeah. Okay. And let's see. Okay, continue. So today, we're going to continue to look at session 7.3 and 7.4. Okay. All right. So last time, we talked about double angle formula, right? And I also tell you that this is the formula for the final exam. So the sum and difference formula, double angle formula, and product to sum to product formula will be given. So you don't need to memorize it. You just need to know which one to use, right? Okay. Let's continue. Okay, here. Graph 4 cosine square minus 2. Okay, cosine square minus 2. Well, there is a square there. Okay, what we have been doing, we can graph cosine, sine, tangent, cotangent, secant, cosecant, but not with the square. Oh, but here we have the square. Well, then what do? Change it. Okay, so look at the double angle formula. This formula, what does it do? It reduces the power but double the angle, right? So we don't want to see cosine square. We want to see cosine. So this double angle formula can help us to reduce the degree but double the angle. Okay, everybody? So cosine 2a is 2 cosine square a minus 1. Let's copy down this. So cosine 2a is 2 cosine square a minus 1. Here, our a is like x. Right, everybody? So our y, well, y is like, do you see the common factor 2? Yeah, bless you. After you factor out the 2, do you see we get 2 cosine square minus 1? Yeah, everybody? Do you see the common factor 2? After we factor out the 2, what's that? 2 cosine square minus 1. Oh, that is exactly cosine 2x. Can you see that, everybody? Woohoo! This is exactly cosine 2x. See? We reduce the power and we double the angle. Okay. That's why we reviewed last class. Last class, we learned double angle formula. Double angle formula, the cosine. We have 3 formulas. But usually, we either use the 2 cosine square minus 1. This formula related cosine to a and the cosine square. And then we either use this formula. This formula related cosine to a and the sine square. Okay? So when you have cosine square, think about this formula. When you have sine square, think about this formula. And then the sine 2a is 2 sine a cosine a. That's why here we have cosine square. That's why we look at the double angle formula involving the cosine square. And then, okay, here we have the 4 and 2. Oh, let's factor the 2. Factor out the 2. Then we have 2 cosine square minus 1. That's exactly cosine 2x by the double angle formula. Okay, now we know how to do it, right? So we draw the table. And theta, what's theta? 2x. Cosine. Cosine, what are the theta values we're interested in? 0, pi over 2, pi. 3 pi over 2, 2 pi. Good. Okay, now what's the cosine theta? Sine and cosine wave. Cosine start with 1. 1, 0. Negative 1, 0. 1. Good. Now the x. See? Theta is 2x. What's x? Yeah, theta over 2. That's why 0 over 2 is 0. And then pi over 2 is pi over 4. And then this is pi over 2. If 3 pi over 2 is 3 pi over 4. And then 2 pi over 2 is pi. Yes, everybody? So, and then, oh, we're looking for 2. So y is 2 cosine theta. Right? And this is like theta. So y is 2 cosine theta. Ooh, 2 times 1 is 2, right? 2 times 0, 0. 2 times -1, -2. And then 0, 2. Yes. So we draw it. Okay. So from 0, you see, it's at most pi. So then you can put pi here. Half of pi is pi over 2, and half of that is pi over 4. And the middle of pi over 2 and pi is 3 pi over 4. And then you look at your x values and the y values. Right, everybody? When x is 0, we get y is 2. So where's 2? Oh, here, 2. When x is pi over 4, my y is 0. And when x is pi over 2, we get -2. And then 3 pi over 4, we get 0. At pi, we have 2. So connect them smoothly. This is the graph. And usually in the exam, I will ask you to draw 2 periods, right? So you kind of, okay, kind of same length. And then you go down, go up like that, right? What is the period? 2 pi over 2, which is pi, right? Because the coefficient of x is 2. Yes, everybody? Yeah, so this example, it kind of relates, use the double angle formula to reduce the power, double the angle. And then we can draw it using the method we learned before. Everybody okay with this problem? Okay, derive a triple angle formula for sine 3x. Okay, sine 3x. Well, first of all, sine 3x is sine 2x plus x. Do you agree? Yes, everybody? Okay, now, sine 2x plus x. We use the sum formula for the sine, right? A is like 2x, B is like x. Right, everybody? Can you see that? So that is sine 2x cosine x plus cosine 2x sine x. Right, everybody? So sine 2x sine 2x and cosine x. So your A is like 2x, your B is like x. You plug into this formula plus cosine 2x times sine x. Yes, everybody? And then, what's sine 2x? Well, sine 2x is 2 sine x cosine x. Right, everybody? Yep, this formula. Sine 2x is 2 sine x cosine x. So 2 sine x cosine x. This is the sine 2x. And don't forget we have another copy of cosine x. And then cosine 2x. Well, cosine 2x, you have 3 choices. Okay? But usually I either use 2 cosine squared minus 1 or use the 1 minus 2 sine squared. How about let's use 2 cosine squared minus 1. Yeah? Let's use that. Okay. You can use any of these. They're correct. Okay, so let's use 2 cosine squared minus 1. So this is the cosine 2x. And then don't forget the sine x. So far, so good, everybody? Oh, You see, this is 2 sine x cosine x squared. And then when you distribute, you get 2 cosine squared times sine x. And then minus sine x. Do you see these two terms? They are like terms. We have one copy of sine and two copy of cosine. So we can combine them. We get 4 sine x cosine square and minus sine x. So this is the triple angle formula for sine 3x. Okay? So we just derive it. Okay. Now, power reducing formula. Okay. So because we have the cosine 2x is 2 cosine x squared minus 1. Solve for cosine. So we add 1 on both sides. Yes, we add 1 on both sides. And then divided by 2. Do you see? We get cosine squared is 1/2 cosine 2x plus 1/2. Where's the equal sign here? Okay, so look at the double angle formula, and we solve for cosine squared. We get cosine squared is 1/2 cosine 2x plus 1/2. Yeah, which is the same thing as this. Okay, so yeah, here if you want to carry out the cosine square, and then you can put it, you reduce the power and you double the angle. Similarly, because we have the cosine 2x is 1 minus 2 sine x squared, you can both sides subtract 1. Both sides subtract 1, and then divided by negative 2. So you get sine squared is negative 1/2 cosine 2x, and negative 1 over negative 2 is 1/2. Therefore, square is 1 minus cosine 2x over 2. Is that okay, everybody? So this is the power reducing formula. They are derived from the double angle formula. And that's why in the formula sheet, final formula sheet, I didn't give you that because you can derive from here. Is that clear, everybody? You can derive from these two double angle formula. Okay, and then the tangent square, tangent square is just sine square over cosine square. That's why I get that. Okay, we write sine to the 4th x as sum of the first powers of the cosines of multiple angles. Okay, so let's do that. Sine to the 4th x. This is like sine square square. Yes, to the 4th is square and then square. Okay, this power reducing formula, we only have the square. Okay, that's why you want to represent it as like square. Sine square is, I like to use the 1/2 minus 1/2 cosine 2x. Okay, so I want to separate them. Okay, it's easier to separate them. Okay, so here, you can separate them. So 1 over 2 minus cosine 2x over 2. Right? And this is 1 over 2 plus cosine 2x over 2. So sine square and cosine square. The formula is very similar. This is 1/2 minus 1/2 cosine 2x. This is 1/2 plus 1/2 cosine 2x. Okay? They both have 1/2 and 1/2 cosine 2x. One is negative, one is positive. Okay, everybody? All right. Now, let's see what happened. So, what is the complete square formula? a squared minus 2ab plus b squared. Right, everybody? Therefore, what's 1/2 square? 1/4. Minus 2ab plus b squared. 1/2 square is 1/4. And then we have the cosine 2x squared. Yes, everybody? And then, okay, do you see this 2 and this 2 cancel? Right? So we have 1/4 minus 1/2 cosine 2x. Oh, you see? We have the cosine 2x squared. Well, here we're going to use this formula. But we reduce the power, we double the angle. So if the angle was 2x, now the new angle will be, when you double the angle, the 2x becomes 4x, exactly. So this is 1/2 plus 1/2 cosine 4x. Okay, we're using this formula, but we reduce the power, double the angle. So if we start with x, double the angle, we get 2x. So if we start with 2x, double the angle will give us 4x. Right, everybody? If you have 5x, double the angle will give you 10x. Exactly. Aha! Let's simplify that. So we get 1/4 minus 1/2 cosine 2x. This is 1 over what? 4 times 2? 8. Yeah. And then also 1/8 cosine 4x. Can I combine the constant 1/8 plus 1/4? What's that? Yeah, 3 over 8. So 3 over 8 minus 1/2 cosine 2x and plus 1/8 cosine 4x. Okay. How many of you need to take calculus 2 in the future? Okay, I'm going to use this later. Yes. Yeah. Okay. Continue. Find all solutions of the following. Well, this is the equations involve trick expressions. First of all, you want to make sure they have the same angle. Do you see this guy has the x, and this guy has the x over 2? They have different angles. So you want to have the same angle. So, do you see this cosine square? Maybe we can reduce the power and double the angle, and the x over 2 will become x. Right, everybody? Yeah? Okay. So this is why we don't change this. We change that. Because the double angle formula will double the angle, we get x. But here, if you use this guy, the double angle formula will change the x to 2x. You don't want that. Alright? Yeah. Okay, so we have 2 minus sine square equals 2 times, okay, what's cosine again? Cosine square. 1/2 plus 1/2 cosine. Double the angle. Okay, everybody? So we put 1/2 plus 1/2 cosine. Double the angle become what? X. Yes, so step 1, make the angle the same. Okay, so make the angles the same. Okay, so here we make the angle the same. So this is 2 minus sine square equals 2. Distribute. 2 times 1/2 is 1. And 2 times 1/2 is 1. Right, everybody? So step 1, make the angle be the same. No, this is cosine x, right? Yes, my mistake. Yes. Make the angle be the same. That's step 1. Step 2. Okay, so you either, if you can factor it, or if you cannot factor it, try to change, okay, the trig functions. So it's in terms of only one trig function. So in this problem, we cannot factor. There's no common factor, right? But then you think about, can we change the trig function so that we only have one trig function? Sine square is related to cosine square, right, everybody? The trig identity, sine square plus cosine square equals to 1. So we can change the sine square in terms of cosine. So here we're using the sine square plus cosine square equals to 1. So sine square is 1 minus cosine square. Therefore, 2 minus sine square is 1 minus cosine square equals 1 plus cosine x. Right, everybody? Okay. What's that? So this is 2 minus 1, and then plus cosine square. Right? Oh, do you see 2 minus 1 is 1? Yeah. And you can subtract 1 on both sides. You get cosine x squared is cosine x. Alright. Now, what do? Move all terms to the left-hand side. Okay, so we add cosine x on both sides. We get cosine square plus cosine x is 0. Oh, sorry, we subtract. No, not add. Yeah, my bad. Okay, so it's cosine x minus cosine x squared minus cosine x is 0. Right, everybody? We'll move all the terms to the left-hand side. Can we factor? Can we factor? Yes. What's the common factor? Cosine x. What's left? Yeah. So once we factor it, then we can set each factor equal to 0, and we solve for x. So we get cosine x equal to 0, or the cosine x minus 1 equal to 0. Right? Okay. Cosine x is 0. Let's see. What's cosine? Wave, you start with what? 0 or 1? 1. So start with 1 and then go like that, right? So when what x give us cosine x is 0? Here, what's this angle? Pi over 2, right? So this is pi over 2. And how about this one? 3 pi over 2, right? Oh, and because all solution, it does not restrict our angle to be 0 to 2 pi. So if you want to collect all of these ones, you should put pi over 2 plus k pi, where k is an integer. So where k is integer. Is that okay, everybody? On the other hand, cosine x minus 1 is 0. That means cosine x is 1. Oh, cosine x is 1. What is that? That is here. Yeah, here and here, right? This is 0, and then this is 2 pi. Therefore, x is 2k pi. Are you okay with that? It's 0 plus multiple of 2 pi. So that's why 2k pi, where k is an integer. So therefore, our solutions are these guys. So far, so good, everybody? Okay, good. So that is double angle formula. And the power reducing formula. Okay, next, product to some identities. So, yeah, I never memorize it. You just look at, oh, cosine, cosine, and then use this one. Sine, sine, use this one. Sine, cosine. And by the way, you realize these two is so similar, okay? These two is so similar. So if you have cosine, sine, you can actually rewrite it to get sine, cosine. So usually we only give this formula is enough. You don't need this one. Okay, everybody? All right. So yeah, we write the product cosine sine as a sum or difference. Cosine sine is, so maybe using this formula is more obvious, right? Or you can change this to be sine 4x times cosine 5x. Same thing. Yes. Okay, so let's use this formula. Now my A is 5x. My B is 4x. Yes, everybody? So that equals 1/2 sine. See? 1/2 sine. A plus B. A is 5x. B is 4x. Right, everybody? So we just pick the formula and then plug in. Minus sine. See? Minus sine. A, 5x, minus B, 4x. So far, so good, everybody? Yeah? All right. And what happened? You get 1/2. What's 5x plus 4x? 9x, right? Yeah. And then minus sine 5x minus 4x is x. Yeah, that's it. Very simple, right? Just pick the correct formula and then identify your A and B and then plug in it, simplify it, and then you get the answer. Okay, so now you're able to do sine 5x, sine 4x. You're also able to do cosine 5x times cosine 4x, right? You just use different formulas. Okay. And then sum to product formula. Okay. Find the exact value of cosine 195 degree and cosine 105 degree. So then you look at which formula. See? Cosine plus cosine. Right here. Yes, everybody? So cosine plus cosine, which is this one. A is 195. B is 105. So that is 2 cosine. See? A plus B. A is 195 degree. B is 105 degree over 2. And times cosine. A is 195 degree minus B is 105 degree over 2. Right, everybody? We just plug in the formula. Okay, now tell me, what's 195 plus 105? 300 and if 300 exactly, right? Oh, over 2, what's that? 150 degree. What's 195 minus 105? 90 degree divided by 2. 45 degree. Oh, now 150 degree is in quadrant 2, right? Quadrant 2. What do? So 150 degree, like here. What's the reference angle? Right? Yeah, reference angle 180 minus 150 is 30 degree. So cosine 150 degree is plus or minus. Second quadrant, your cosine is plus or minus? Minus cosine 30 degree. What's cosine 30 degree? That is root 3 over 2. Exactly. So negative root 3 over 2. Okay. So this is negative root 3 over 2. Cosine 45 degree. Root 2 over 2. Root 2 over 2. Aha. 2 cancel. So negative root 6 over 2. So that's the answer. Okay, everybody? So if the angle is not in the first quadrant, then you find the reference angle and figure out that trig function is positive or negative. Okay, everybody? Let's see. We have one example. How about, do you mind if we finish this one? And then, yeah, in the next class we can start the 7.5. Okay. So sine plus sine. Sine plus sine is the first formula, right? The first formula, sine plus sine. So that is, this is A, 5x, B is 3x. So 2 times sine. A is 5x, B is 3x over 2 times cosine. A is 5x, B is 3x over 2. Okay? Right? We're using the first formula. We plug in A is 5x, B is 3x. Okay, now tell me, 5x plus 3x is ax over 2, 4x cosine. 5x minus 3x, 2x over 2, x. Okay, here, don't change the angle. Do you see it's already a product? Perfect. If you get the product of two factors equal to 0, you just set each factor equal to 0. Don't change the angle. We don't need to. Okay, it's already a product of two factors. Set each factor equal to 0. Okay, now this is the tricky part. Sine. Okay, sine. What angle give us sine is 0? Well, it's 0, pi, and 2 pi. Then you can say, oh, that is k pi, right? So, oh, but now our angle is 4x. So let's say this is sine theta. Then your theta is k pi. But in this case, our theta is 4x. So 4x is k pi, where k is an integer. Can I use this notation? K belongs to the set of integer. Okay, then there's less thing to write. Okay, now we solve for x. Both sides divided by 4. So we get k pi over 4. On the other hand, cosine x is 0. That is what? That is pi over 2 or 3 pi over 2. But we can combine them. This is pi over 2 plus k pi. So therefore, our answer is this. Okay, k pi over 4 or pi over 2 plus k pi. Okay, thank you. See you on Friday. Have a nice day. So next class we'll talk about 7.5.